Modern Android development. If you've been an Android developer for more than a year, perhaps you're getting a feeling of deja vu. Why? Because over the past several years, in almost every major conference, there's been a talk, Modern Android Development. Don't believe me? Here we are, Android Makers, April 2018. Devoxx France, April 2018. Google I/O, May 2018. Android Developer Summit. And it goes on and on and on. At the time, the practices and tools presented really were modern. But from here on out, I'd like you to think of them as classics. They serve their purpose in helping Android to become the global leader in native application development. However, many of the solutions left much to be desired. We're going to go through a short history lesson to understand where we've been and what's led us to where we are today. So first, SDK M3, that was all the way back in 2007, believe it or not, and time has flied. Since then, there have been more and more platform APIs, Android Studio. I just remember being in the crowd where, oh my God, we can't believe it, Android Studio, Kotlin support, architecture components, app bundles, etc. Now, back in the day, the main language of choice was Java. Java had a large developer base. There were a ton of existing free tools. There were loads of libraries, patterns, best practices. It just made sense that we would use Java for Android development. And we also used to have Eclipse. I can't tell how many people, but if you just want to put in the chat, like, yep, I was around for the Eclipse days. I remember Eclipse. It was definitely a tough experience, but the bonus points was, it was free. And if you were doing some web development, then you were already pretty familiar with Eclipse, and we could integrate new tools into the IDE. And previously for the APIs, there were new releases to the core SDK platform frequently, and there was always new functionality in all the different releases. But although there were all these things, it didn't really help users in the previous releases. So when we kind of look at a timeline of when the SDKs were updated, they were updated very, very often in the beginning. And then it slowed down to more of a yearly cadence. And now let's talk a bit about distribution. It was all about the APKs. Everything was zipped up for our convenience. If you had more configurations, then you had more APKs. Or you had bigger APKs, whatever the matter was. But even though APKs were nice, there were some obvious downsides. So as we've seen so far, the classic approach to Android development came with a few classic problems. Namely, it was a poor developer experience with a cumbersome IDE. There was inconsistent user experience with each platform release, where we get Android fragmentation from. And finally, it was a somewhat clunky distribution mechanism with the use of the APKs. The answer to that is modern Android development. And by modern, we mean the development tools, the APIs, the language and distribution technologies that are recommended by the Android team that can help developers to be productive and create better apps that run across billions of devices. Modern Android development sits on top of the following foundation, platform and play, with the following pillars. So the language, the tools, the APIs, and then the distribution. We'll look at each of these one by one. First up is our modern language, Kotlin. Here's a short history of Kotlin on Android. Back in 2016, there was 1.0 of Kotlin. Then in 2017 at Google I/O, the official support was announced by Google for Android. And then in 2019, we said, hey, we're Kotlin first. And now coroutines are preferred, and that's pretty much where you are today. But why Kotlin? Kotlin is a very expressive language. That means less boilerplate code that you have to write. It's safe. There's a strong type system. nullability at the language level, the interop, it can work with Java, so it's really easy to migrate things, and then the structured concurrency. So this is where we're talking about coroutines, asynchronous programming, and avoiding that callback spaghetti. But mostly we just love the language. Let's look at an example. Here we have this bundle with the question mark, nullability in the type system. Then we look at Lambda support. We get this very nice, concise syntax. Things are more succinct and readable. Extension functions. They make the helper code more discoverable, and it also helps to fix API problems in a compatible and release agnostic way. Next up, we have this template expression. These things are compile time checked inside of strings, way easier, more succinct than format strings in Java. Also, properties are built into the language. You don't have to have any more confusion between private and public or getters and setters. What else about Kotlin that's so interesting? Well, of course, it's the speed. There's so much less to write, and also the speed of the language evolution. They're constantly improving the language as well as the runtime libraries. Coroutines was experimental last year. Now it's fully supported. Flow helps support streaming values, and then extension methods allow many features to evolve outside of the language. Meanwhile, developers seem to like it. 60% of pro Android developers use Kotlin. 70% of the top 1,000 apps contain Kotlin code. Now, besides that, Google is working really hard to improve Kotlin support. They've been adding new things to the tooling, like blend checks and a dedicated compiler team. They're also expanding Android KTX. If you haven't checked out the documentation recently on developer.android.com, it's pretty cool to see the way that they've reorganized it to make it more obvious how you can use Kotlin inside of your Android applications. Also, they've been annotating platform APIs. This makes it easier as we decide to hook up our code to take advantage of the native nullability that comes with the Kotlin programming language. So if you, like I said, if you check out the website, you'll see that they've reorganized things. There's a lot of new documentation, samples, code labs, courses, etc., that can help you take the most, get the most out of working with Kotlin. Now, for our modern tools, it's Android Studio. Android Studio brings the power of IntelliJ, which is great code writing and refactoring, with built-in capabilities for Android. The release of Android Studio happened back in 2013, and I remember sitting in the audience at Google I/O hearing the shouts of joy, and then watching hundreds of Android developers try to download the IDE over conference Wi-Fi. It didn't really work, but that's just how excited everyone was to take advantage of this new tool. Since then, there have been so many improvements and new features, like the embedded profiler tool, the visual editor for constraint layout, and much more. As an example, we talked about how it uses powerful code refactoring. If you're working in Android Studio, you barely have to type anything. You can use intent actions and it mostly does the work for you. There's also an extensible UI for future tools. We talked about the new visual layout editor, but there's now also a motion layout editor. And there's very tight integration with Kotlin and Gradle. In the latest release, there's full support for Kotlin scripts if you want to use that for your Gradle files. It's really impressive how quickly the team keeps updating the IDE. And then finally, there are lint checks and quick fixes that I mentioned to help you avoid some common mistakes, and integration with existing and new APIs. So speaking of APIs, Android Jetpack is what we're doing for modern Android development. With Jetpack, APIs are unbundled and they can be used across releases. But we're not going to talk about all of them today because there are a lot. We'll just look at a subset. Constraint layout, you can think of it as relative layout plus plus. Lets you build a rich UI with interrelationships between the views, including constraining those views to guides. There's also motion layout, which is a subclass of constraint layout that allow you to have really seamless animations and transitions inside of your app. And this is tightly integrated with the tools. So it's literally built to work inside of Android Studio. And life cycles. How many of you have seen this really complicated diagram to understand the traditional activity lifecycle implementation? It was probably very overwhelming. I remember back in the day interviewing for Android jobs, they would ask you, now what comes after on start? And that's gone. We don't have to worry about all of this in our activity anymore. Now we're just focused on app compet activity and the lifecycle owners. Get a lifecycle object, set an observer on it. That's it. The observer can implement any of the lifecycle events, and it can also query those lifecycle states like you see here inside of the foo function. Another new feature from Jetpack is the live data and view model support. View model stores live data objects which can be observed, and this helps to separate data from the UI. Any elements in the UI can register as observers of the live data changes, and then the changes can be sent to the UI. Meanwhile, the data layer can talk to something like Room, and this can help us to query the database to return a list of items. Room is easy to work with. You can create custom queries, just like you see here with the get all function, or standard queries via annotations like @insert, @delete, or @update. Also, notice how you see suspend functions? That means that coroutine support is built into the Room library, which is really sweet. You can also do something like use the material design paging library to talk to Room and return a page list of objects. There's so much functionality available in Jetpack, and you can even find new project templates for working with these things together. Like view model and live data, those things are lifecycle aware. This helps you avoid leaks. Room can be accessed via view model and live data objects, and Room uses coroutines and flow. So all of this works together. And if you want to use ArcsJava, that's fine. They're also ArcsJava friendly. My kids just came home, so you'll hear like random screaming in the background. So let's talk about another thing, the navigation component. New Studio templates make it easier to create applications with navigation built in. You can access them from the navigation component. You can add a new navigation, new destinations with actions going between them right from inside of Android Studio. And here's some of the underlying code that you can see for the navigation graph that's created for you. And then finally, the code to navigate to a destination is trivial. We're going to call our controller and navigate from the first fragment to the second one. Work Manager. This is how deferrable work is handled. You can do this in the background. It's compatible all the way back to API level 14 plus. And it has support for periodic tasks, chain sequence parallel tasks, and defining execution constraints. For example, maybe you want your background to work only when the person is charging their phone, or only when the battery is at a certain state, or only if they're over Wi-Fi. Work Manager handles that. Here's a use case. Let's say you have a beautification app that filters images, compresses files, then it uploads them to a backend. The image filtering tasks can all happen in parallel, and then subsequent compress and upload tasks can only occur when the previous stage has been completed. And then for each task, you can even associate criteria for them to happen. Do you have enough battery? Do you need to have enough storage for the compression task? And maybe the user has decided, well, I only want to upload files when my device is connected to Wi-Fi. Work Manager can handle all of that for you. When we look here inside of our Work Manager, for each task, it's implementing its logic within that do work function, and that work should either return the result, success, or failure. Then we can implement a chain of work for our photo beautification use case. So for each task, there might be some optional constraints. For example, if the battery is running low, then we may not want to run a power-intensive task such as the image processing. And you can do the same thing, setting up these constraints and then chaining them all together. But we're not done yet. We still have to add those last two tasks, compressing and uploading to the chain, and then call in queue to begin the execution. When I look at Work Manager and how far we've come with background work, it's really impressive. There would have been so much code to do this prior to using something like Work Manager, and now it's basically given to us for free. There's also new support for important work. You can start these things as foreground services. Here's an example of a worker that's using Coroutines API to do some work. And then we're just returning success, and that's it. Finally, I want to talk about the CameraX library. I haven't had a chance to play with this one yet, but I am very curious because it has these three main benefits. First of all, it works with the majority of devices over API level 21. So that gives your app great coverage. If you've worked with the camera features before, you know that different devices may have different camera characteristics, but the CameraX library provides an abstraction over these things, and it also handles the camera lifecycle for you. So in CameraX, they have something called a use case. And there's like three main use cases: previewing, image analysis, and then capture. And you can kind of see an example of each of those use cases. And then here's how you wanted to do that. So suppose you want the app to take some pictures. Then you would create and configure this image capture object. You can give it a config to say, okay, this is the resolution of the picture I'm looking for. And then you can decide, all right, I want to handle the life cycle. And there's so many different features available. And then just the interaction, take the picture. And basically with 3 lines of code, you can have an entire image capture pipeline. And that's it for APIs. Next up is modern distribution. And this is a new way of distributing apps, and that's the app bundle. So it's not all about the APKs anymore. As far as distribution goes, we announced the Android app bundle back in 2018. And what's interesting is that many users have very limited storage on their devices. In fact, 3 in 10 phones have less than 1 gigabyte of internal free space. And constrained storage leads to uninstalls. Users without free storage are almost twice as likely to uninstall compared to users that have free storage. Meanwhile, the larger the APK, the more likely it is to have issues with installation. So the size really does matter. On the other hand, the data shows that smaller downloads mean more installations for an app. And app bundles achieve these smaller installs by only downloading the config data needed for a particular device. Legacy APKs, on the other hand, download everything to every device. And this leads to either bloated APKs that are too large or configuration-specific APKs that have to be managed by the developer. Another way to visualize the per configuration downloads is to look at it this way. App bundles are providing you with a dynamic delivery. So not every single thing has to go to every single device. And we can see that here because they enable dynamic feature delivery where app modules can be delivered as per needed. And so far, a lot of developers are using it. I'm curious if you all are using app bundles already. I know we are at my company, and it was actually a pretty seamless move for us. Wasn't too challenging. And I really encourage you to do it because that one switch automatically decreases the size of what's delivered to your users. And typically, you'll see about a 20% download size savings versus a monolithic APK. So let's put this all together. Modern Android development is about the language, the tools, the APIs, and the distribution that sit on top of this foundation of the Android platform along with Play services. And we talked a lot about Kotlin and the IDE and the Jetpack, as well as using app bundles. If you want to know more about this, please visit d.android.com/modernandroiddevelopment, where you can find a reference to these different resources that I've talked about today. Thanks a lot for your time, and I would love to answer any questions that you have. So I will take a look at the chat. And okay, let's see. Blah, blah, blah. And I'm just going to start at the top and see if there's some questions I need to. I used to love Eclipse. Okay, you're alone. Oh, no, wait, there's another person who also loved it.
It's not just me.
Wow, I can't believe it.
I think there was a question around backwards compatibility with Kotlin to previous versions of Android.
Okay, let me see. Hated Eclipse with all my heart. Yes, Mateo, that's me. Okay, I love Eclipse. All right, okay. How far is it? Okay, so I still use Eclipse. Wow, okay. And I do hybrid apps with AngularJS because I need to support older devices. How far back can we go with Kotlin? How far back do you need to support Android? Oh, I guess that's a weird question. But for Kotlin, you should be good. Like, you should be able to support back to, I don't know. I don't know anyone doing anything less than like API 7. You should be able to support at least back to API 7. That's a good question. I'll try to find an answer for you, and I'll post it in the Meetup chat. I don't really see why there should be a limitation, but just in case. So, and who asked this question? Mr. Becker? Okay, I don't know. I'll just write that down. I'll remember. Okay, so how far back can we go with Kotlin? Okay. And then just a whole bunch of love for Eclipse. So, okay, yeah, someone already answered that. It's just like Java. So if Java works, generally Kotlin works too. Yes. Okay. Okay, just more talking about that. Hybrid dev, blah, blah. Have you tried Hilt for dependency injection? No, I read the documentation though. If I were to do a new project, I would maybe use it. When I'm doing my side projects, I use Coin because it's in Kotlin and it's really easy to understand. But if I had to do an app from scratch that I knew was going to be large, then I would use Hilt. Let's see what else. What needs to be done extra for app bundles? Oh, okay. It's a different Gradle command. Like literally, that's mostly it. There's a different Gradle command that you run to generate your app bundles. And then you generate your one app bundle. So if you were a person who was using multiple APKs before, you would no longer use that multiple. If you were using like ABI splits at some point, I know my old company, we were doing like ABI splits. We were splitting the APK in so many to try to get our APK smaller. You don't have to do that anymore. You generate the one app bundle and then you upload it to Google Play. And then there's also something called like the internal sharing page in Google Play now where you can upload, where you can upload your app bundle to test it out. So, and the second person asks the same question, how do you get started with app bundles? If you go to the website that I talked about with modern Android development, they walk you through what you need to do. But essentially, that's it. It's a separate Gradle command. I use coin too. Yeah, I know. Why coin? Okay. I prefer coin over Dagger because I don't want to have to do a lot of setup that Dagger requires. That's the main thing. With coin, it's maybe like 2 files, and then there I am, dependency injection. It's really simple, and it's easier for me to understand as far as testing. I like to write unit tests, and I still have never fully figured out how to get it right with Dagger, and it's just like a pain. So that's why I prefer coin. Anything new in the testing framework? I've heard some words about nitrogen, but I still haven't really seen them pushing anything in testing yet. But I know that there's some work coming with nitrogen. And what else? So work manager. Is there something consistently? If you want to run something consistently at a certain time, you have to use alarm manager. Like that's the only solution. Work manager is optimized for your whole device. So it's trying to run work at the same time or in parallel as much as possible. So if you want it to be super consistent at a certain time, then alarm manager is it. Runs on all over. Okay, thanks, Robert. So yes, Kotlin runs on all versions of Android. Someone saying something about Dagger. Coin is meant to be for Kotlin. Dagger is really hard. Is coroutine Google's replacement to ArcsJava? I'll say coroutines is JetBrains replacement for ArcsJava. Yeah, you should use coroutines for asynchronous work. Oh, I'm sorry about that, alarm manager. Okay, any other questions? This was fun. These were great questions. Speaking of coroutines, my team, we did a mobbing session where we just ported one flow from ArcsJava to coroutines. And when I first brought it up, everyone was like, get out of here, Annyce. We're never going to do that. And then by the end, they were so excited and they wanted to just port everything to coroutines because the code was just way more intuitive. When you start doing like subscribe on, blah, 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 and then you get to the view model and it's just view model scope launch, all the things. It won everyone over. So that was pretty cool. I'm like super proud of them for wanting to do that and for us tackling that work. Anything else? Find me on Twitter, Brown Girl Dev. If you have separate questions, I'm always happy to answer them.
Awesome. Thanks so much, Annyce. That was amazing. Everyone said so in the comments. I was reading them too. So I'll screenshot that for you. I think Jared caught your quote of the day. What did it quote? All the things.
Right.
Oh, very cool.
So
Yeah.
cool.
If you have any more questions, you can bug Annyce on Twitter, like she said. You can send them to us on Meetup chat or however you want to do it, and we'll be happy to. Or you can watch this on the YouTube channel and put it there.